So, Algebra 1, this is 8.6. Today we are going to factor. We're going to factor trinomials with trinomials and solve trinomials here when a is equal to 1. So what we need to do is we need to factor it into this so that I can set them all equal to 0. So I can say x plus 2 equals 0, x minus 3 equals 0, or x equals negative 2 and x equals 3. How did I get those? Subtract 2 from both sides. Yes? Add 3 to both sides. Yes? So therefore, that's how we're going to solve our trinomials, is that if you factor it into its factors, which is what I have here, I can set each one of these factors using that zero product property and solve for them. So each of these, when I plug them into this equation, or the equation that would result when we multiply it, would make it 0. So not only do I want to show you that, let's take a look at this here. And I'm going to copy it and paste it. Okay. What happens here if I FOIL that? So what would the original problem look like? It's x times x. Whoops, not that one, this one. X times x, which is x squared. X times negative 3. So negative 3x. 2 times x, 2x. And 2 times negative 3, negative 6. That's what you guys had to do in the last couple lessons. And of course, we got like terms in the middle that we will add, not multiply. So we're going to add these together. That becomes x squared minus x minus 6. That was multiplying. We've done that before. Our goal now is to not go from here to there. We're going to be given this, and we have to write it in factored form. We factored out greatest common factors, and we factored by grouping. Now we're factoring trinomials. Notice that a is equal to 1. There's nothing out here. That's a 1. So these actually are pretty easy. I'm going to use this exact one so we can see that we get the same result as when we started with when we multiplied. Here are your rules. So factoring. Maybe even a trinomial. Number 1. This is where a equals 1. So maybe above that, put a equals 1. Factoring trinomials. Number 1, find factors of c. C, remember, is the constant. What is the constant in this problem? Negative 6. For now, let's just ignore the fact that it's negative and say, what are the factors of 6? That would be 1 and 6, 2 and 3. Would you guys agree with that? Okay, so we found the factors of C. 2. Find the pair that gives you B. Find the pairs from number 1 of C that can give you B. And B in our problem is negative 1. Now, what I mean by that is by adding or subtracting. So one of them can be positive, one of them can be negative, or both positive or both negative. So the question is, will 1 and 6 ever be able to give me a 1? Like 1 plus 6, 1 minus 6, 6 minus 1, or negative 1 minus 6? Any combination ever going to give me a negative 1? No. There'd be something completely different. So then that one's out. So you go to 2 and 3. Is there a way to combine them to get a negative 1? And the answer is Yes. And what would that be? What combination of 2 and 3 would get me to a negative 1? A positive 2 minus 3, right? So guess what? Step number 3 is we're going to set up our parentheses, our factors, with x and x, because these ones are going to be x and x, or if the variable's an n or a g, it'll be g and a g first. And then you're going to fill in with the pair that you chose in 2, and then you will have to use the appropriate signs. I know it's pretty vague in its explanation, but I want it to work for all of them. So we have x and x, because it's the only way to get x squared when you FOIL first, right? First times first. So that gets x squared when I rainbow. Now, we have to use 2 and 3, so I'm just going to put a 2 and 3 in. I'm going to put the pair in. Now I just have to say, what are the signs going to be? But how do I get to a negative 1? You said it's 2 minus 3. That meant the 2 had to be positive and the 3 had to be negative. And then obviously step 4, if you want to put a step 4 in there, check by FOIL. Check your work by FOILing. FOIL this back together and you find out that it is the same. Now if you look above, we have all of them. It's the same answer as we got here. Now, we just basically factored this problem. And if it was saying solve it, well, then everything from every step, this step here, would have said equals 0, which means these equal 0, which would lead us back up to what we did up here. So let's do some examples. So let's factor this. Let's solve it, actually. So we're going to solve this by factoring. So we're going to go through all the same steps, but when we get to the bottom, when they're factors, we're going to set all those factors equal to 0, and then find out what they should be. So, first step was what again? Find the factors of C. What's C? 20. So, what are the factors of 20? 1 and 20. 2 and 10. 3? No. 4? And 5. So we have 3 options for this one. 3 options. Which one of those options can give me a 9? The 4 and the 5. So we know that it's going to, factors are still going to equal 0 because the equation itself equals 0. X and X always for these ones. And I'm going to put a 5 and I'm going to put a 4 in. Now you just have to worry about your signs. Now here's the thing. This is how you figure out your signs. 20 is your last of FOIL, which means I need to take 5 times the 4 to get a 20. That 20 is positive. There are 2 ways to get a positive. If both numbers are positive or if both numbers are negative. But here's the thing. They have to add up to 9 when you put them together. The I and the O of FOIL get added together. They're like terms. And since that's positive, both of these have to be positive. Here's the nifty little trick is, if both of these up here are positive when you're factoring, then both of these are going to be positive. We're not done yet, because we're going to take each one of those and do what? Set them equal to 0. We're going to solve it. Which means subtract 5, x is equal to negative 5. Subtract 4, x equals negative 4. You're done. Next problem. Oh, the b value is negative. Changes it slightly, not much. Still, factors of 12. 1 and 12. 2 and 6, 3, and 4. Which one of those can give me an 8? 2 and 6. So it's x and x, 2 and 6. They're going to multiply to get a positive, 12. But when you add them together, give you a negative 8. So how can 2 and 6 be put together to make you a negative 8? What would it have to be? Both of them would have to be negative. Because a negative 2 plus a negative 6 is negative 8. That obviously equals 0. You guys starting to make a connection here when they're simple like this? What's the value of x here? What makes that 0? 2. What makes this 0? 6. So x equals 2, x equals 6. When they're simple like that, hopefully eventually we get to the point where we say, we know the x value, it's 2. We know it's 6. And the last one, now C is negative instead of positive. What are the factors of 15? 3 and 5. Anything else? Okay, which one of those pairs can give me a 2? 3 and 5. So we're going to use 3 and 5. It's x and x, 3 and 5. If they have to add up to a positive, but yet multiply to a negative, that means one has to be positive, one has to be negative. But it has to be positive in the middle. That means the bigger number has to be positive. The only way to get a positive 2 with a 5 and a 3 is if it's positive 5 and a negative 3. So it's minus positive. What's the value of x? X equals? First one? What's x going to equal to make that 0? And the next one? Negative 5. That's it.